Well, good morning, everyone. I'm Ryan Siegel. I'm here from SEDAC, or the Smart Energy Design Assistance Center at the University of Illinois, here along with my coworkers Robert and Sean. So, how many of you are familiar with SEDAC at all? A fair number, actually. Above average this morning. So, give you a little bit of background here in a minute, but before we start, planning on taking, we'll go for about 50 minutes, and then take about a 10-minute break, and then go for another 45 or so minutes, and then we'd like to do a little bit of a roundtable discussion and get your feedback and input on challenges of the energy code that you are encountering as far as compliance, implementation, knowledge, and the like. So, as far as who we are, as I mentioned, we are at the University of Illinois down in Urbana-Champaign, and we are a public-private partnership, and our private partner is 360 Energy Group out of the city of Chicago. So our primary goal, or our mission, is to reduce the energy footprint of the state of Illinois. So that's both public and private sector. And we realize that the energy code and the state's adoption of it is a key factor in that going forward. So today's training is provided by the State Energy Office, formerly housed in the Department of Commerce and Economic Opportunity. It has since moved to the Illinois EPA. So that's one of those that some people aren't necessarily aware of that. So if they get a call from IEPA, it may actually be energy related rather than enforcement related. So as far as our office, we've got several different ways you can reach out to us. Our technical support, our 800 number, more predominantly is our email address, energycode@sedac.org. And we also do have a lot of online resources at our website. Many of those resources not only are information, but also archived versions of past workshops, as well as several webinars. We give between 4 and 5 webinars a year, typically around lunch hour, and we make those available afterwards. We also have online on-demand training. So we have a set of modules out there that covers the various aspects of the energy code. The main ones are, we have a residential module, and then we have 3 that are on commercial: the building envelope, the lighting, and the HVAC and mechanicals. So those modules are designed with more of an introductory audience in mind. So those can be good for building owners and even some homeowners and occupants may be able to make use of that as well. So they take somewhere about an hour to an hour and a half to complete a module. So it's designed to be for those people who can't necessarily travel, or they might work second or third shift. So this is an ability for them to get some training at their ability and leisure. So this is a look at our website. So if you go to sedac.org, you'll find energy code training up in the upper right-hand corner. And then our training menu is on the left-hand side there. So you can see, workshops, webinars, as well as frequently asked questions. Those will be updated soon. We're moving to the 2018 code cycle, which, for those who are likely have been waiting with bated breath for this, we're presently anticipating the Illinois will adopt the 2018 IECC beginning July 1st. So permits after July 1 will be on the 2018 IECC rather than the 2015. City of Chicago went ahead and started theirs June 1st. So there's a little bit of a shift there. But the city of Chicago looked and said, you know, this date was originally March 1st, then April 1st, then May 1st. So city of Chicago said, June 1st, we're not waiting anymore. So with that, as far as codes itself, you know, obviously we typically adopt codes for health, you know, safety, and the welfare of buildings and their occupants. Now, state of Illinois has 3 statewide codes that they adopt. And that's our plumbing code, energy code,
Life safety code.
and accessibility code.
Well, and also the life safety code.
Life safety code might.
That falls on our NPA.
Okay. So with those, and that's regardless of municipality or jurisdiction. So everywhere else, that or the other codes, they leave up to jurisdictions to determine what codes they're going to follow. One problem we do run into with this, because it's jurisdiction by jurisdiction, is you end up with many different sets of rules, depending on where you are at. So it's not uncommon in a county to have 3, 4, 5 different codes that you're having to follow, depending on where you are in the county. And so with that, you know, that is one benefit of the state of Illinois adopting a standardized energy code, is you don't end up with, okay, where is this located? What do I have to comply with? What do I not? Which version is it? It becomes a little more standardized. And so that's one that, with codes, there also are different ways. This has come out in development more recently, which I guess technically is over the last 25 years, is moving towards more model codes being adopted rather than individual cities trying to build and maintain their own code system. Even the city of Chicago has done away with theirs. They have moved to the model codes, which, I mean, city of Chicago's building code, I mean, we're talking dating back to Great Chicago Fire, you know, over 100 years of code. So one thing we have found that is a nice feature is the energy code. When they have built it, there's not a lot of things that overlap between the energy code and the other building codes, in that if you have a different version, it doesn't end up causing you a lot of conflicts. So the only conflict that we have identified so far, or the major one, has been the vapor barrier. The vapor barrier, if you are on a building code that is older than 2009, you may have a missing vapor barrier, because before 2009 it was in the energy code, and starting in 2009 it moved to the building codes. So with the energy code being newer, if you have a very old building code, there may not be a vapor barrier. So that is something to be aware of. But that vapor barrier is going to be important for the longevity of that building and the occupants. So something to be aware of. So this kind of gives you a flavor as far as the various I codes. This is put out by the International Code Council for states and jurisdictions to adopt. Some of the more common ones are obviously the building code, residential code, and maybe property maintenance code. And you can see the energy conservation code is one of them. So, as far as this, we don't have too much in the way of national building codes, but they're developed more on a national basis. So the International Code Council and NFPA are both national organizations that develop model codes and standards for adoption, and then it's up to states and localities to adopt whatever the codes that they find appropriate for their jurisdiction. So something that we have come across in some locations is cities and even counties have kind of come together and said, okay, rather than everyone having their own codes and figuring out, well, okay, I'm on the 2005 over here, and I'm on 2008 over here, and 2011 over here. As a county and the municipalities within, we're all going to move to a standard code, and we're all going to move together every so often. In one instance, they've decided about every 6 years they're going to move. So they're going to adopt every other code cycle, which allows for, easier for training and things of that nature, where I'm not having to relearn a whole set of rules, plus getting codes through the rulemaking process takes some time. So I said, okay, every 6 years we'll adopt a set of codes, which also helps the contractors in that area, because now the contractors, they're all operating off a single set of rules, and they don't have to worry about, okay, where is this house going to be built? Okay, now I need to make sure that it's compliant with that set. So, as far as some of the keys here, ICC develops model codes, ASHRAE develops model standards. Very closely related, but a little bit different. But then it's up to the individual jurisdictions to adopt and then enforce which codes or standards they're going to use. This was something that was kind of interesting. We came across trying to do some research because we had seen some older codes out there. The International Code Council is only 25 years old. They've been developing and trying to develop these standardized codes for adoption. So, and we've seen that trend moving across the country here. So as I noted, one challenge with municipalities doing the adoption is you end up with a lot of different ones. You can see it's almost kind of a bell curve here. Adoption seems to be presently somewhere around 2006 to 2012, which you're talking somewhere between 7 years and 13 years old is where the majority of codes are presently. So there appears to be something with the 2009 code that people haven't necessarily liked. And so jurisdictions either stopped before getting to 2009 or have continued past it. So that may have something to do with fire sprinklers, I'm betting. So now looking at, here we are in Carterville, and so we figured the state of Illinois has a published list of these are the codes that are in effect that have been reported to us as these are the codes. If a code is not reported to the state, then the state has adopted a set of defaults. The default code is the 2006 IBC, Existing Building Code and Property Maintenance Code, and the 2008 National Electric Code. So in the absence of a local jurisdiction having an adopted code, those are the defaults. So this, here at Carterville, we see some of these are rather old, 1995, 1996. So as reported to the state of Illinois, a building built today is being built to a standard that's over 20 years old in this Carterville jurisdiction. So now some of these, when you look at Boca hasn't been around for quite some time. And you can see here several of these old building codes were last published before the turn of the century. So one consideration municipalities may decide to, if they want to update their codes, is perhaps just doing away with theirs and moving to the default. Which, again, even that default code, you're talking 13 years old. So Also pulled a sample building permits. This is a fairly brief 2-page permit application as far as what's being done. And something that we noted was at the end, here we are referencing several of these older codes and noting Capital Development Board, Energy Conservation Code isn't even up here yet. So some of this is, evolutions in needing to do some updating. So with that, I'm going to turn it over to Robert and talk a little bit more about the adoption process and the code cycles themselves.
While you're doing that, is there anybody that reaches out to these municipalities that have severely dated codes to encourage them to update or do any kind of adoption? Who would take the lead in that?
That would, I don't know that there necessarily is someone that does that. State of Illinois has kind of tried to take a hands-off approach that it's whatever you want to do. As far as the building codes for the state of Illinois, that is through the Capital Development Board. So the CDB is actually the one over it. Their big one right now. There is some discussion in their office. They would like to see the state move to a little bit more of a modern code than the 2006, because that was adopted in 2011 as of the 2006 version. So being that adoption occurred 8 years ago, they're looking at saying it might be time to move 1 or perhaps 2 cycles forward. So another thought that may be out there is looking at it and saying, because right now there is no floor. So you can, there's several municipalities out there that have codes from the 1970s, still as their adopted code. Looking at that and saying, perhaps maybe we need a floor that says, your code cycle has to be within 15 years. Once we get past 15 years, this floor is going to come up and meet it.
So that'd be something to be a state statute, just like the plumbing code and energy code.
Correct, yeah.
Add that language.
Correct, yeah. The state statute was what adopted the default code, and so they would have to go ahead and do a state statute to revise that. And realizing that we don't necessarily want to, it's not always good design practice to necessarily be on the forefront, and be the first adopter. Because as we've encountered several times in the energy code, it's not uncommon where it takes 2 or 3 code cycles to get the wording to really mean what I was going for originally. Where some of that, you go to implement some of the text, and it's like, that's not easy to implement. That wasn't quite what I meant. So we have seen some of that evolution, and that's where looking at it and saying perhaps making a floor that raises behind. So municipalities do have the flexibility to adopt and try things out. So as that floor comes up, they can implement better on a statewide basis and say, okay, it looks like these are common amendments that municipalities are taking. Let's grab that and pull that into the state.
I can tell you from the architectural practice in Carterville, if we have projects, it doesn't get designed to those codes. It gets designed to the 2006.
And that's the case in Carterville.
Most of the time it's because that's what's on their ordinances.
Mm-hmm.
So when people are looking to report that, that's what they say. Well, this is what our ordinance passed, was the 95 vote.
Yeah.
Most of our submissions are above and beyond what we enforce.
Yeah. So that, and maybe that may perhaps be something we'll take a look at, reaching out to some of these communities and saying, do you wish to continue that practice, or do you want to go ahead and just take that? Because that list of adopted codes across the state of Illinois is well over 100 pages of adopted codes. So, okay.
It's pretty amazing how dated some of these the communities are that Ryan was talking about, that list. some pretty old codes out there. BOCA ceased to exist in 2004, and there's still a lot of references to BOCA out there, and it'd be nice to kind of get on the same page. You know, it really is a hodgepodge of codes across the state. So you have 10 states where the cities can adopt the codes versus, you know, being imposed by the state across the board, which I personally think that imposing a code across the board from the state is maybe a better approach, because I remember when I was working for an electrical contractor back in the late 70s, early 80s in Champaign-Urbana, there were different codes. You cross the street, literally, and it's a different set of codes that you're playing by, and that drove the contractors crazy. So it really is a hodgepodge of codes. I hate following Ryan because Ryan's so much of a better presenter than me. This is what I'm looking for. Okay. So the Capital Development Board is basically running the show here in the state. They're the ones that the Energy Efficient Building Act stipulated that you will update the energy codes every 3 years, and they will be adopted by the state. So we are current as far as energy codes across the state, but not other building codes necessarily. So as Ryan mentioned, the effective date is July 1st, tentatively. The Capital Development Board, as you can see, for state-funded facilities right there, it used to be always you must comply with ASHRAE 90.1. Well, that's changing now. They're anticipating that's going to change, that you will be able to also use the IECC for state-funded facilities, which opens up certain possibilities. So that's a fairly large change, not having to use 90.1, because there are some things in 90.1 that aren't in the IECC that makes it fairly expensive. Individual controls, and mostly on the electrical side of things. So you can see here that buildings use a lot of energy. They use about 40% of the energy here in the country, in the United States. Transportation uses quite a bit. In industry, it's a smaller portion, but still large. That represents about 5 million commercial buildings, and I think it's about 115 million residential buildings. So that's a large building stock, right, that's consuming that much energy. And that represents about 8% of the world's carbon dioxide emissions. And buildings use about 70% of the, or 72% of all electricity in the United States. So, and that's particularly noteworthy because, you know, we're seeing fossil fuels being used, like when you use natural gas in a building, you know, you're running it hopefully somewhere around 80% efficient to well into the 90s if you're actually using a condensing boiler. Well, when you're using electricity, we still produce a lot of the electricity using coal. So I can give you 6 units of energy at the plant. Well, you're only getting to use 2 at the building because we've lost 4 of those in production, transmission, conversion. So there's a real implication there that this electricity is kind of it's an expensive commodity when it comes to CO2 emissions. So, you know, why are energy codes important? This is just the electrical side right here. You can see that of that 70% commercial, residential, and industrial, that's split fairly evenly, industrial being the least. Residential, we've got appliances and electronics, about 30% there, HVAC, 26%, lighting, 12%, water heating, 10%. And then on the commercial side, we've got a lot of other uses which we wouldn't see in residential. We've got HVAC about 26% in lighting, 20%. The nice thing is, you know, as all of you know, we're going to a lot of LED lighting. much more efficient than our older forms of lighting, particular incandescent, and even a lot more efficient than a lot of even our good fluorescent lighting. And what that means is we're putting a lot less heat into our buildings, meaning we can also downsize the HVAC, because now we don't have to extract all that heat that we put in our buildings with our lighting. Even though some of the T8 and T5 lighting is very efficient, the LED lighting is even more efficient. We're proponents, when I first started at SEDAC, which was about 2004, the only thing we were recommending were LED exit signs at that time. So that technology has really changed over the last 13 years, or 15 years. So that's, the technology is really changing, and some of our HVAC technology is changing too. Some of our heat pump technologies have gotten extremely efficient. We can actually, the old heat pumps really didn't work very well down below 30 degrees or 35 degrees. The newer heat pumps can actually extract energy out of air that's, negative 15 degrees. So the newer heat pump technologies are fairly impressive, and especially for climates like down here if you're going all electric. So we have this history of model codes. You can see we start out here in 75. This is back, I'm one of the older ones in here, by that oil embargo. That's when we start realizing that, hey, this is not a good deal. We're so dependent on other countries for our oil that we need some codes for our buildings. So we established codes back in energy codes, the model energy code back in 75. So you can see that goes for a while until 86. There was some improvements at that time. And then another improvement on the commercial side. This is commercial and residential. 1989, we made a fairly major improvement right there. We used the original codes as the baseline of 100. You can see on the commercial side, we made a big change there in 89. Now it's down to 86 right there. So we're only using 86 units of energy instead of 100 for our commercial buildings. You can see a small incremental change here in 89. A big change in 2004, and another big change here in 2010. Other than that, there's smaller incremental changes along the way. And same thing on residential. Here we had two major changes back in 2000 from 8 to 9, and another just 3 years later from 11 to 12. So that really sends designers and contractors and code officials into a tizzy sometimes, because there's so much change going on at that point. So here we have Chicago was the first in Illinois to adopt energy codes. 2 years later, the state goes, "Hey, we're gonna impose this on state facilities." 3 years later, the state goes, "We're going to have all commercial buildings in the state comply with energy codes." That was in 2007. And then 2010, the state said, "Okay, now we're going to impose this on residential too." So, they put it into effect here. And then just 2 years later, there was a new code in effect. So that there's a lot of learning curve going on in each one of these steps. So that makes it a little tougher. Yeah.
Is that based on actual energy used that they've tracked, or is that just based on a model?
These are probably based on models,
okay,
would be my guess.
And it's based on models per square foot.
Yeah.
Yeah. But you can see, based on models, we're down to 48 here on the commercial side. I think that's 53 on the residential side. So that's a huge change. That's a huge improvement from where we were in the 70s. Implications of that are, less energy use and probably more comfortable buildings too. The residential compliance is a little harder than the commercial, just because there's so many different residences being built versus just many less commercial buildings being built. than residential. And usually you have design professionals down here involved with the commercial, whereas residential, it's you just don't have as many design professionals involved in that process. So, you know, how do we get there is, well, it's the energy codes that are driving this, and it's a lot of it has to do with some of the stuff we're going to be covering, air sealing and addressing thermal bridges and stuff like that. The Midwest Energy Efficiency Alliance, MEA, they do a lot of code type research, and they surveyed, I think it was 69 code officials from the state of Illinois. And you can see what are the biggest issues enforcing the energy code was the question. Well, and this is, so we're talking to code officials. Well, the code official said, well, it's a lack of understanding from buildings and designers. and if you ask that question to builders and designers, that graph would look very different. So you know, obviously this has got a bias to it. But this is in regards to compliance. So, you know, with these new codes, it's a changing field. So, I mean, it's hard to sometimes keep up with some of this stuff. So on the enforcement side, some of the responses were lack of knowledge base for code officials to interpret energy codes, contractor resistance, energy code is not a priority, which I can understand that sometimes because, you know, health, safety, and welfare is the primary for code officials, what they're looking for, and we want to make sure our buildings don't collapse and things of that nature. They don't burn down. So there's some, if they don't meet code as far as energy, well, okay, they're going to use a little more energy, but at least we have a building that's not going to collapse on somebody. And then lack of enforcement from town to town, which that's enough to drive designers and builders crazy. Importance of existing buildings in energy codes. You can see here when these code officials were interviewed, most of the permits they're giving are for existing buildings. It's not for new buildings. So we're touching a lot of existing construction and it's not new construction that code officials are dealing with. And when we talk about existing buildings, the most important sentence here, or is the last part of this sentence, is construction without requiring the unaltered portion of the building or building system to comply with this code. So when we're applying these energy codes to additions and remodels, they only apply to what we're touching. It does not apply to the rest of the building. And that's important. And there are also instances where if we're working on a roof, for example, a low slope roof, and we're doing a tear off, and the code says you've got to put R30 on there, but you're looking at it and you say, well, this was designed to have only about 10 inches of insulation. We've got curbs for HVAC RTUs up on top of the building or parapet walls, and if we put R30, it's going to, you know, wreak havoc on everything else. The code allows some flexibility, the code official, to say, well, do what you can. You don't have to meet that R30, but if you can put on R20, that's good, you know. So there is some flexibility in that code.
Does it not say in there, though, if you're like renovating the interior space and you remove the drywall, are you still not obligated to replace the exterior insulation once you've exposed it? If you were taking out this whole wall in here,
You're required to keep it, you're required to, if it doesn't have insulation in it, if you take drywall off the
Yeah.
wall, if it has insulation,
You
you
can
can
leave
leave
it.
it. But if you're taking it off, then
Then
all
there
you
is
have to do, you still have to put back in whatever will fit
It
within
can.
that
Okay.
cavity.
Right.
I knew there was something with the
And
insulation.
generally, if it's it's a 2x4 wall, you can get a 15 at least.
Mhm.
You
Yeah.
have to fill the cavity, but
Right.
you don't have to bring it all the way.
You don't have to take out if it's existing and replace it with new.
Yeah, there's a lot of grandfather type clauses in that, yes. So, you know, these energy codes, they're touching everything. They're touching the walls, floors, ceilings, it's touching the everything, the envelope,
I'm going to
HVAC.
add one more thing to that for your designers, if it's helpful, and correct me if I'm wrong. But if you have, a lot of times nowadays you're trying to renovate storefronts or old buildings and stuff that have that exposed brick for restaurants, and you want to maintain that look. So that's already exposed. You can leave it exposed.
Mhm.
You don't have to go back and add to it.
Okay.
But anything you do touch, pull off, or whatever, then you need to at least fill it to the,
And you can't make it worse than it started.
Oh, I know.
So if there was a wall in front of your masonry wall,
Yeah.
and the masonry is load bearing, you can't take the wall out with all the insulation and leave the masonry.
You can do that. You can take the cosmetic part off of that wall, but you need to put it back in place or make it up somewhere else.
Yeah.
Right, right. Could be on the outside of the
Or you
building.
could build up. I mean, you could run across where they'll just build up the roof and make it up in the roof, adding more insulation to the roof.
So we're touching everything in the building, basically. The energy codes are quite extensive. You can see they're broken down into, on the residential side, we've got the building thermal envelope, the systems, and the electrical power and lighting. So R402, R404. It's towards the end of the back of the book is the residential portion of your IECC 2018 book that you got there. So the systems are the ventilation and ducts, HVAC and water heating. Lighting is this electrical power and lighting systems, and then obviously our fenestration. So it's broken down into those three main areas. And on the commercial side, we've got the HVAC, which is basically by itself because we pulled out the service water heating, and then we once again have the building envelope. The reason this is pulled out, in commercial building, the service water heater can consume a lot of energy. You get into a laundry or a car wash, or we've been in some skyscrapers in Chicago where the hot water systems in those huge storage tanks and large boilers up in the penthouse. So there's a lot of energy that goes into service water heating for some of these systems. The nice thing about the IECC is you can, you've got a code book, but you can also get online and you can look at all the different versions of the code. So you can go back in history and pull up all those different versions, and you can look through the whole book for free. I mean, it's a great feature from the IECC. This applies to their other codes too, the IBC, the IRC. And you cannot cut and paste text out of those PDFs that they have. They're protected, but everything's online, so it's a real handy reference. It's your turn.
The ICC has also done a real good job as far as searchability. So if you're not necessarily know exactly where you're looking for in the code, the search function works really well in the ICC codes. ASHRAE also does make theirs available online at no cost. I will say their search function is much weaker though. So that's one. It's not uncommon where when we're in our office and trying to answer a code question, it's not uncommon where I'll actually go to the online version before I might end up in the book, just because it's much quicker to jump right to the section. So. As far as are we in commercial or residential, that's one of the big challenges. As Robert noted, this code book is separated into two sections. You have commercial provisions in the front of the book and residential provisions in the back, which if you send us an email about code questions, whether it's, we're here to serve anyone in the state of Illinois or state-related project. So whether it's, homeowners, design professionals, contractors, code officials, we're here to help you. But if you send us a question, if you can help guide us as far as are we in a commercial or residential provisions question, that will greatly help so I don't end up in the wrong section of the book and give you an answer that doesn't make sense. So, but as far as Illinois has actually adopted a slightly modified definition of residential building from the code book. So for Illinois, they have detached 1 or 2 family dwelling and any building 3 stories or less with multiple dwelling units where occupants reside on a primarily permanent basis. They also have an amendment to add it's 4 stories or less in Chicago. So city of Chicago gets an extra story on that. So, and they also list several examples as far as these are residential. So as far as the first one, we've got a 5-story mixed-use building, 2 stories of retail, 3 stories of apartments in Chicago. Am I going to be residential or commercial? Predominantly. Commercial. Yep. I got 5 stories, so I'm above the 4 for Chicago. Next, 3 stories in Carbondale. My residential or commercial, predominantly?
Commercial. Residential.
Residential.
Even retail?
3 stories or less, I'm predominantly residential for my apartments. Retail, I may have some commercial provisions that may sneak in.
Electrical and HVAC.
Yeah, but predominantly the building, the outer shell, I'm predominantly in residential provisions. 5-story single-family home.
What's your house, Dave?
Commercial.
This one's a little sneaky. Since it's single-family home, it's residential.
That's 5-story.
Single family.
Oh, under residential.
Single or 2-family home,
Oh, under the-
regardless of height.
Under the energy code.
Energy code. Yep. Yeah, these are energy code related, which that brings up an interesting question. You can end up where, depending on which code you're in, you might be in a residential provisions of one code and commercial in another. So this gets a little funny. 3-story hotel. Commercial. Yep. Not on a permanent basis, so I'm commercial. So, as far as compliance, we've got a few different options for commercial. So predominantly we see most people use IECC, either prescriptive or performance. Performance being an energy model. This is not ComCheck. ComCheck is actually a prescriptive compliance method. Or the IECC allows you to use ASHRAE 90.1. So again, Robert noted controlled receptacles. That's generally one of the reasons why people don't like 90.1. So we see mostly IECC, either prescriptive or performance for compliance. So with prescriptive, we'll also call out this C406, which requires you to add an additional energy efficiency measure. The code, as you saw earlier, has not changed dramatically from the 2015 to the 2018. The code has now become more about usability and flexibility. And this is one way they did it, is with this additional efficiency measure, you can choose which one do you want to use for this building. So you might have a building where, I can get more efficient HVAC real easy. I'll take that one. Another one might choose lighting. So it provides you some flexibility as far as compliance. So, on the residential side, we've got 3 primary paths. Again, we've got prescriptive like commercial, performance, and then we also have the energy rating index, which is closely related to the older HERS rating. So it's slightly different, but it uses the HERS
Is this in
standard.
Is this on your, do these slides, where are they on here somewhere? Or something?
You should have a slide packet.
Oh, okay.
There we go. Yep.
Yeah, thank you.
Yes.
They're
And also
like
these.
crazy.
Yeah. And these are also going to be posted to our website as well.
All right,
So,
thank you.
if someone else that wasn't able to be here today, you can direct them over and they can pick them up too. ResCheck is actually using this UA trade-offs. Is what it's using as far as its compliance for ResCheck. So, no. And the ERI is now using the ResNet ICC standard 301 for compliance. So we'll touch on this ERI because that was a major change. Have any of you dealt with any HERS rated buildings yet? Couple? Okay.
We're about
we-
98% of our residential service.
Really?
About 90%.
Okay. That is highly unusual. Rarely do we see, it's uncommon to see HERS rated yet. But they've made a change in the code for 2018 substantially that may make it more attractive. Far as climate zones, a lot of the code talks about, particularly in the building envelope, what climate zone are you in, what standard do you have to meet. Here in the state of Illinois, right, we're down in 4 and 5. Down here we're in 4. As you go north, we're at 5. Something I will note, the ASHRAE 90.1 map is slightly different. That line is much flatter in 90.1. So these counties in the middle have changed climate zones. So that may push you one direction or the other. So if you're right on the bubble and you're in one of those counties that's in a different climate zone, depending on are you in IECC or 90.1, that might be something to look at that may push you to go one direction or another. So, as far as the structure, we had talked a little bit about this. We've got our prescriptive requirements, but then we have several mandatory requirements. Mandatory requirements are there regardless of which compliance path you choose. So, and noting they can't be traded off for others. You have to comply with it. So, some of these do allow you to do some trade-offs, but only to a certain extent. We'll talk about one of them, which is in renewable energies, as far as how much you can take advantage of a trade-off. So, one thing that the city of Chicago has done that we do like is they've made this fairly simple form as part of their building permit process, which is, how are you going to comply with the energy code? Go ahead and tell us which method are you doing, so when I'm doing a plan review, I know which one to go look at. So I know what to expect. You know, if you check, I'm doing a energy rating index, I know I better be looking for that ResCheck or that ResNet report on there. You know, if I'm doing prescriptive, okay, I'm going to be looking at the blueprints as far as the specs that you've called out. So, and then at the bottom they also called out, here are all the mandatory provisions for you. Go through as a checklist. Did I get this? Did I get that? You know, did I comply with all of these? So this is one form that they've put out that we think might be a nice practice to adopt. And similarly, on the commercial side, here the form gets a lot longer because of all the different ways you can comply with commercial. You have IECC, you have 90.1, you have the various ways you can comply with each one. And here, again, we talked about that 406. Which extra measure did you go after? So again, makes plan review much easier and simpler. So, which that's something else is we're looking to be a resource across the state of Illinois. So if there's certain forms like this that you as design professionals or as code officials say, hey, it would be helpful if we had, had a form or, something where we can go through and certain checklists that might be useful, let us know so that we might be able to help develop those to be a statewide resource. So far we've just kind of been looking around and seeing, well, what are other places doing? So this is one that we came across for City of Chicago that we're like, that's a very nice practice and might be helpful. So with that, what do you say we take about a 10-minute break? Now we're gonna kind of transition here. So as far as what's new in the code, the good news to a lot of people is there's not really been a significant energy change from the 2015 to the 2018, or for ASHRAE 2013 to 2016. There hasn't been a lot of improvement, just a couple of percent. There's been a lot of reorganization. Again, this code cycle is more about usability and flexibility, and how do we get the wording better. So the mechanical, they totally rearranged, but tried to get it in a little bit more orderly fashion. They did pick up 2 extra 406 measures, which is better envelope and reduced air infiltration. And as far as in the previous code cycles, it said, the system shall be capable of, this system shall be capable of. Well, that's great. I have a programmable thermostat it has all kinds of capabilities. I didn't program it to do any of it, but so now it says, be capable of and configured to. So things such as setbacks, in thermostats. The code originally thought, well, I said you should be able to set it back. Well, I can. I won't. There's a new appendix, solar ready zone. This isn't adopted by the state. Local jurisdictions may choose to adopt this. We're not seeing a lot of adoption at this point, but it might be something to take a look at as far as practice. And it's really more about identifying on the plans where future renewable energy systems might go and planning for that up front. It's a lot easier if I have the space already on the wall to put the inverters rather than trying to cram them into a janitor's closet later. So things of that nature. I noted earlier the climate zone map is a little different in these 6 counties. So in the IECC, these are in the colder climate zone. In ASHRAE 90.1, they've moved to the slightly warmer zone 4. So, Appendix G, this is predominantly for LEED projects that we see Appendix G compliance with ASHRAE 90.1. So that's another way to comply. Residential, very similar, no significant change in efficiency. Definition of approved has dramatically changed. It used to say acceptable to the code official based upon tests by him, her, or a nationally recognized testing laboratory. It now just says acceptable to the code official, period. So providing a little bit more flexibility. Again, a lot of what we're dealing with is renovations and alterations. These are buildings that are 100 years old, if we're lucky. They're 100-year-old buildings. Trying to get them to fit to the energy code isn't always easy. And so trying to say, did you do what you could with what you had? So, inspection, is it exposed? Well, that's great, but it can be exposed, but is it visible? I have to be able to see it at the time of inspection when I'm supposed to. So this is predominantly in the inspection section where I believe it calls out 5 different inspections. So, and with that, I'll turn it over to Robert to cover some of the commercial provisions.
Okay.
I got a question on the residential, this is the code, when you're talking about its changes, is it in the IECC, or what about the Illinois changes? Were there any significant changes?
Illinois amendments,
Yeah.
there has not been any significant residential amendments. The predominant amendments for Illinois has been dealing with roofs, and particularly those low slope roofs. That seems to be the big push this time. The Illinois amendments, particularly on the residential side, mostly is actually just pulling in things from the IRC tables for ventilation. So there's not a whole lot as far as actual amendments. They just pulled in as far as how many CFMs per bedroom. Well, there's a table in the IRC that says here's how much CFMs of ventilation air you need. The Illinois amendment is take that table and put it in. And that's part of the Illinois Energy Code. And that's it.
Unless you're under the 96, we don't have an IRC.
Well, and that's where with this, well, and that's where the ICE, the Illinois amendments is actually pulling in the most recent table.
All right.
So even if you're not in an IRC division, they've pulled the table into the Illinois IECC.
Kind of like if you're going to use a bath fan for your mechanical ventilation requirements, and you're going to put a timer on it, it actually puts that table for the CFM and the timers and all that.
Correct.
In there as well.
Correct. So that's most of what the Illinois amendments are on the residential side, is
Right.
just pulling in those IRC tables. So that way, if you're even in a non-IRC jurisdiction, it still applies.
So is that available now online, or is that something that's once everything's adopted, then it'll be all?
The 2018 amendments have not yet been posted.
Okay.
We anticipate that JCAR, the Joint Committee on Administrative Rules, is going to be voting on it this week. So hopefully it will be published, fairly soon thereafter. The 2015 amendments are already out there.
Yeah.
And so there weren't a lot of Illinois amendments. The only one that we'll talk about later that's kind of major, kind of not, is on lighting. Was their big residential amendment this time, which was the definition of what constitutes high efficacy lighting. And when we went to just pull what products that are available readily on the shelf, 85% of them met the new requirement already. So that's why most all the LEDs comply.
As far as transition, I know like under Illinois, technically this is state, you got all projects, but I mean, is there a grace period, or because I'll be honest with you, my municipality, we're still under the 2006 building code. We're under 2015 IEC.
Mm-hmm.
We're trying to adopt the 18 I codes
Mm-hmm.
in the next year or so. But as far as transition from 15 energy code to the 18, we're not going to just jump on board.
Permit application of July 1 is the state of Illinois.
Well, yeah,
And that's where
but there's no real honestly there's no real enforcement of it. So I'm just.
That's the truth.
I'm just
Yeah,
out here,
you're right.
Maybe I should say my comments.
I understand that is
Round
reality.
table.
Yeah.
So that's why this is the letter of the law as far as how the municipalities will enforce that.
Right.
That is.
I realize we need to enforce this A code, whether get to the 18 eventually, but we need to enforce something. You need to enforce something. Otherwise, you're going to lose out on a lot of other state grants and.
The shift from the shift from the 15 to the 18 is not that substantial. I mean, that's, as we had seen from that chart earlier,
Yeah.
you know, there was a whole lot of heartburn
Oh,
when the state adopted the energy code, because we went from no residential energy code to a dramatic change, and then 2 years later, another dramatic change.
Yeah.
So that's one that we can appreciate the heartburn that caused. From the 15 to the 18, a lot of it is more usability
That's good.
stuff, which, you know, we actually had seen some projects around the state that code officials would ask us, hey, they're wanting to go ahead and use the 2018 codes now. Is that allowable? I'm like, if they want to, I mean, I don't see any issue of if you want to go ahead and jump from the 15 to the 18 early, because there's certain provisions that allow better usability. That's a jurisdiction call.
So is the July 1 thing set in stone now because they said May 1st a while back and they said no, or is that subject to change again?
It is still subject to change until JCAR votes on it. So that's where that vote is anticipated to occur this week. So the latest information will always be on our website as of the time of that posting. So we don't know of any other hiccups because it has, part of that change was JCAR sent it back to CDB to go through another iteration of the process. Now that it's gone through that process, we don't foresee any other roadblocks because they have addressed the issues that they sent it back for. But again, it's the state of Illinois.
Yeah, what you're talking about is reality and enforcement. You know, yeah. Sometimes it's enforced, sometimes it isn't. So, as far as commercial, not all commercial buildings have to comply with the building thermal envelope. There are certain exceptions. Very small buildings, your buildings that house electronic equipment that don't have any offices or really occupied spaces, buildings with very small loads, things of that nature. So Ryan mentioned this, section 406 earlier, that you have to comply with one of those 8 provisions here, the more efficient HCC, reduced lighting power, and these 2 were added in the 2018, the enhanced envelope performance and reduced air infiltration. Those are really big issues. I'm going to just quickly touch on those. The enhanced envelope performance, a lot of that deals with thermal bridging in our construction. And thermal bridging is a big deal. I found this on the web, this building thermal envelope bridging guide. It's from Canada. Canada has done some very good building research in the past. And this is a great publication. If you're anyone interested in the thermal envelope and bridging issues, this is a great reference to take a look at. You can pull it up online, and that's a link to that publication. Like I said, thermal bridging is a big deal. You see here a wall section that's got, if you look at just the R20 between the steel studs, and then we've got some sheathing, and then our Z furring strips, and then some more insulation on the outside, our continuous insulation, air gap with hat channel and some type of siding. You look at that and you think, well, gosh, that's 32.6. That's pretty darn good. Well, when you take into the bridging the effect of those metal studs, that wall is actually only R14.3. So not a really great wall. It makes a huge difference. I did a lot of consulting with HUD where we went to Indian reservations. We were looking at mold and moisture problems and things of that nature. And I can show you pictures of mold 16 inches on center at a wall to ceiling junction where you've got 2 top plates, you've got a low heel truss sitting up there. These are in cold climates. And those spots got very cold. We would take the temperature of that wall in the field where the insulation was, and it would be 10 to 12 degrees warmer than up where those top plates were, where those low-heel trusses were sitting, because you just couldn't get a lot of insulation up in there. And you've got the exterior vents, you know, letting air up into the attic in these places, and those little spots on the wall were just colder than hell than the rest of the wall. And all the moisture in the air, well, what's it seeking? It wants to condense on cold areas on the wall. So those were the first spots, 16 inches on center, where those trusses hit the top of the wall, where mold would form. So that was all due to thermal bridging. And this is was a SEDAC project. This was a clinic, a new medical clinic in central Illinois that we went to in 2011. And so this was the picture from the inside. This is what we're looking at. And this is this picture with a thermographic camera, where we're actually looking at heat transfer. You can see that the difference in temperature in this picture right there goes from 41 degrees to 69 degrees. So the warm portions on the inside are right in here. Those are 69 degrees, and then the window itself is pretty darn good around the perimeter. The frame of the window obviously is a little cooler. You know, we're going here in 2011. Like I said, it was a new building. I'm thinking, why are we going to a new building? You know, this doesn't seem right. Well, they told us when we got there that we occasionally have in the winter on a cold day, we got frost on the windowsill. The windowsills on the inside were stainless steel, and it would get so darn cold that moisture inside would freeze on the windowsill. So there were all kinds of thermal bridging problems with this building. And as you can see here, these are the studs, I think in that same room. So here we're going from 64 to 75 degrees at 11 degree delta T. Well, you can pick out the studs, obviously. You can actually pick out the fasteners that were used to hold the drywall up to the wall. So you can see the effect of that thermal bridging. And thermal bridging is typically about anywhere from 20% to 25% of your wall area. So a fair amount of wall area is a thermal bridge here. So this is what the continuous insulation is supposed to mitigate. You know, I can guarantee you there's no continuous insulation on the outside of this building beneath the brick. So we've done it. It was a very nice building. It's beautiful on the outside. It was beautiful interiors, but you've got these problems going on. Like I said, they called us in because of these bridging problems. You know, what do you do at this point? You're, pardon my language, but you're kind of screwed. You know, you've got this brand new building, and the thermal bridging was not addressed. So what's the solution? Well, you can't do really anything on the inside of the building. That's out of the question. So the one solution was, and I think we probably put this in our report, was put an EIFS on the outside of the building. You know, you're getting rid of your brick, unfortunately, but you're at least providing some continuous insulation on the outside. And to me, this is, I'm an architect, or former architect. This was an architectural problem. You know, this should have been addressed by the architect with continuous insulation on the outside in the design. So this is so thermal bridging is really a very big deal, and we're finally recognizing that and addressing that in the codes. The other big deal is reduced air infiltration, and the codes are starting to take this very seriously too, where we realize that a lot of our energy use is to mitigate air leaking into our buildings or out of our buildings. So now the code is requiring pressure testing of houses and the commercial buildings. And if it's a large commercial building, we only have to test portions of that building. You know, you can have the reduced air infiltration. You can have air infiltration due to the stack effect, warm air wanting to leave out the top of the building and then draw air in down low, Wind effects, you've got wind pressure on one side and then suction on the other side. Mechanical systems, oftentimes if they're not commissioned properly, they'll either over-pressurize the space or under-pressurize space if we do have too many exhaust fans running. So it's a whole host of factors that can add or contribute to our air infiltration. And once again, out of Canada, another very good reference on air leakage control. And the link is right there. It was basically for multi-unit residential, but this applies to commercial buildings just as much as it applies to residential. But a very good publication on how to reduce air infiltration. And that really is a biggie because as our buildings get tighter and tighter, they're just obviously getting much more energy efficient. There are some implications to that. In our travels at the Indian reservations, we went into some new housing that was very well built. And we were asked to go through it because one of the houses already having mold problems. It's a fairly new house. We walked inside that house and it was like a sauna. It was so humid inside. They're warm and humid. Well, these buildings were designed to have air-to-air heat exchangers. Well, the residents had turned off that air-to-air heat exchanger because they thought, well, this is costing us too much money. Well, it is costing you money to run that thing, but these things are these air-to-air heat exchangers are really energy efficient. Panasonic, Braun, they all make them. Lennox, they all make these air-to-air heat exchangers. And they are very effective. What they do is they bring in that cool outside air, they preheat it with the air that you're rejecting. We'll take a look at that in just a second here. And then bring that dry air from outside that's preheated inside, and that absorbs moisture. When you turn that thing off, you've got all that moisture building up inside this very tight house with nowhere to go. And our old, newer houses, there's not much capacity to absorb that moisture. I live in a 100-year-old house. It's as leaky as can be. So not only that, there's wood all over the place. There's lath and plaster. There's solid wood flooring. There's solid flooring underneath, subfloor beneath that. I mean, the older houses are like sponges. They can absorb the moisture and release the moisture, no problem. New houses, well, what do you have? You've got a 5/8 half-inch or 5/8 inch piece of drywall with plastic behind it. So really not much capacity there. You've got a vinyl flooring on top of plywood, which is basically a vapor barrier too. So that moisture has nowhere to go. So it starts getting absorbed into that paper face of that drywall. Well, paper loves to grow mold. And there are mold spores all over the place. So this house was having these problems because you have all this moisture with nowhere to go. So that's where they're saying these newer buildings are more like systems, and they are, and when you take one part of that system and disable it by turning that air-to-air heat exchanger off, you're in trouble, because that moisture has nowhere to go. Our buildings are getting more complex. There's no question about that. Just like vehicles and everything else in life. I remember I used to rebuild the engine in my VW van many years ago, back in the 80s. And nowadays, I don't even open the hood to my car. It's so complex. It's a Prius, and it's just like I don't touch it, because I don't know what's going on. So buildings are getting much more complex too. So as far as building thermal envelope compliance, we've got these different methods. We can go through a checklist. We've talked about some of this already. R-value based, or we can use a U-factor based, or we can go through a component performance alternative. So these are all in the C402 section, which is has to do with the envelope. And here's just a copy of a portion of the C402 table. You can see you guys here, down here in southern Illinois are zone R4, and what applies to this zone as far as R values, the same with the U values in the climate zone 4. And then we have the component performance alternative, which is where you're looking at, well, both this and this unit, where you're looking at the actual assembly versus not just looking at the insulation. You're looking at the entire assembly when you're talking U factors or C or F factors. So this is more the performance of modeling.
So as far as other changes, this is one of the ones we've come across several times now, and that is heated slabs, particularly as we get into garages. But a lot of people like heated slabs. Previously, the code called out for this side insulation to be whatever its normal R value is, plus, if you're doing a heated slab, add R5 to whatever value's in the table. They've now moved that so that the R5 has to go under the slab. So again, we're trying to provide that thermal break between that floor and the soil underneath. So you think about it. What's the comfort going to be if I thermally break that slab from the cold ground underneath, and I now have a nice heated floor under my feet? That's going to be a very nice thing. Now, this is one of those, unfortunately, an opportunity for the wonderful value engineering, which is, the difference between an R5 and an R10 is fairly minimal as far as cost-wise, maybe 30 cents a square foot difference for double the insulation under that. So that's one of those potentials for engineering some value into a project, is saying, the code is requiring an R5. As a designer, I might say, well, let's go ahead and make it, instead of 1-inch foam, I'll put 2-inch foam down for not much more money. But here we just picked up on this little detail yesterday. I have a beautiful thermal bridge right here at this connection. So being aware of how am I connecting that, and am I going to be able to thermally isolate, put something to break that thermal bridge right there. So as far as combustion appliances, this is a big deviation between the model code in Illinois. This has been removed from Illinois as far as if you have atmospheric combustion appliances, predominantly furnaces and water heaters, because you're pulling outside air in for that combustion, you need to thermally isolate that room. Obviously, there's a fairly, relatively speaking, less expensive option. Rather than trying to build this thermally isolated room, just go to sealed combustion appliances and you're done. But so far, Illinois has just amended this out and said, it costs too much to build these rooms. Take it out. Now, if you don't thermally isolate that, well, you now have cold air inside your thermal envelope that, again, cold, moisture, mold, not a good situation here. VFDs, this has moved down. Used to be between 7.5 or 5 and 7.5. It's now down to 2 horsepower and larger motors are now required. There is an allowance if you do have DDC controlled systems that does allow that to go up some. In these, the reference as far as where this is, I do have the reference up here called out as far as what the section number is. And when you get into commercial, one of the biggest things that we come across in a lot of buildings that we see is this reheat. A lot of buildings use a lot of reheat because they're ending up moving more air than they need to. So now this is particularly overcooled in the winter or in the summer, and now I got to reheat all that air that I just paid to cool. So I've now paid to move more air, I've paid to cool it, and I've paid to heat it. So I've gotten to pay for that air 3 times to not really accomplish anything. So this has moved down from 30% to 20%. So now requiring a 5-to-1 turn down for HVAC equipment. Again, shrinking this yellow triangle where I'm not really providing a lot of benefit, trying to get that cost and energy consumption down. Vestibules. This is something that we've gone a couple of different directions on as far as, and finally the Energy Code has provided some guidance as far as, do you provide extra conditioning to the vestibule so when the door opens to the inside, I don't get that cold blast, or how are we supposed to manage that? The Energy Code now calls out, here's how you manage the energy from that. As far as, only enabling heat if it's below 45, and you can only heat that space to 60 or cool it to 85. So this is calling out that vestibules are to be tempered zones. They are not to be conditioned or over-conditioned. So, now we have, it used to call out that water heaters had to have heat traps. It now calls out that storage tanks also need heat traps, because what's a water heater other than a storage tank with a heat source? So they've now just included that. So now if you're storing hot water, needs a heat trap. It could be a physical heat trap such as the one depicted here, or commonly it's just a little device that screws into the water heater.
I see a problem with this because plumbers, it's not in the Illinois State Plumbing Code, so they don't do it. They only follow that.
Mm-hmm.
They don't insulate their pipes. And so at final inspections, this is never done. And it's something that states should change to make plumbers do, because they don't care about the Energy Code.
Yes. I'll make sure I make a note of that, because that's something that in our conversations with CDB and part of their updating,
Mm-hmm.
I think that's an excellent catch, that we need to make sure that we're coordinating between our codes, because we need to make sure, we used to never talk about this.
Right.
And now that we do, okay, now let's make sure we coordinate that.
And then on final inspection, when you tell them they haven't done any of this, they say it was done by a state licensed plumber.
That's great. It's not built to code.
Right. And they get an argument on who's supposed to pay for doing it.
Yeah. So, okay. Yeah, we'll bring that up to try to pick up that. This is a new one. We're not seeing it too much, but as sensors get cheaper, luminaire level lighting controls. So every fixture will have its own sensor for daylight harvesting, occupancy, and the like. So there are some provisions, rather than putting in centralized control systems, every fixture can have its own. So some, again, additional flexibility. Because these sensors are getting cheaper, we're now seeing this starting to enter the market. One of the big things is it has to be able to be wirelessly reprogrammable. So you can change which switch and which sensors tie to which fixtures. So, occupancy sensors, again, this list just keeps growing year after year. The underlined is the new text. So the big one is open plan office areas. And the ones with the asterisks have their own provisions in the code. So how the code is written is, first it covers, I believe, warehouse storage areas. These areas must have the following. And next, I believe, open plan offices must have the following, X, Y, Z. And then all other areas that require aux sensors. So these are the two. And when you look at this list,
Not much left.
there's not a whole lot left other than hallways, mechanical rooms, stairwells. There's not a whole lot left. But yeah. As far as open office areas, This is one where the zoning, this requires that 80% of the luminaires must, or you must reduce lighting power by 80% once an area, a particular zone of not greater than 600 feet has become unoccupied, and once the entire open office area is unoccupied, all of them must go off. So when it gets into that 80% threshold and then the extra, the remaining 20%, you know, you can tie them together, or you can just basically make them independent zones and the whole thing goes off in that zone. So
like in that example, if somebody walked into that room and only sat in the very front row, only light those lights.
then when someone first, if these were tied in code minimum, if someone came in and sat in this chair, the lights that are directly over this zone of 600 feet can go to 100%. All the remaining could go to 20%. Because at least one zone has been occupied, so all of them can go to at least 20%.
So that you automatically kick the whole room.
The whole, correct. The zones must be limited to 600 feet. So that's one of those where you look at it and you say, the controls required in order to know that, okay, someone came in here, so all of these come on to 20% except the one that was activated. And then you got to intertie those. That can be a lot of extra effort to not only install those, but then commissioning all of that. So it might be easier to just have 600 square foot zones and they all act independently and they all control 100% of their lights. And they're done, rather than having to intertie it all.
And 6 months later, the electrician comes in and takes the officers out. It's a regular switch.
We just had a new office building in Carterville that had a bunch of individual like manager offices, all of them having occupancy sensors, and about 50% of them were programmed incorrectly. They didn't come on when you walked in, they shut off too soon, and there's lots and lots of trouble. And the electricians spent a week in there trying to solve it.
Yeah.
We have one of those in our building. In one of the restrooms, I walk in there, I can't turn the damn light on sometimes.
Well, that's what's worrying with that open office plan is, okay, now you're going to tie that system into an emergency system because you may have to exit through that space, and if it's in failure and none of them come on, you really need an additional emergency lighting system.
We're coming
Yeah,
up
but
on.
the emergency lighting's all separated anyway.
Not
Yeah.
always.
Yeah, we're
Probably
coming
in
up.
that one it would be because those are a lot of can lights. But.
This is my favorite exception. Rarely do I like to call out exceptions in the code. This one by far is a great one to use, and I highly encourage the use of this. And that is for daylight responsive controls, and that is if you are able to reduce your lighting power by 40% of the weighted average area. We'll talk about that in a little bit. If you get below that 40%, you don't have to do daylight harvesting at all. Any ideas where that 40% might have come from? What's the impact of daylight harvesting controls? About 30 to 40%. So if I don't put the watts in to begin with, I don't have to install the daylight harvesting controls.
I think they started designing occupancy sensors for energy conservation before everything started switching to LEDs. So now you're spending hundreds of dollars on additional design and equipment when you're putting stuff in that's using a tenth of the electricity you used to.
Yeah. So here's an example. You know, if I've got half my square footage is daylit, I need half of that 40%. So my starting budget was 158,000 watts. If I get the final below 126,000, I am done with daylight harvesting. I don't need to buy it, I don't need to install it, I don't need to commission it, and I don't need to maintain it. So this is by far one of those very powerful features that I really like. I wish they had a similar thing for occupancy sensors too. But so far they've just got it for daylight harvesting. Maybe in the next iteration of the code. But yeah, saying put in more efficient lighting and you've gotten your savings and we're done and we keep all the costs down. So. Exterior lighting used to be just you had shut off for exterior lighting, either daylight or time switch. Now requires both. Also adds you have to have a lighting setback of at least 30%. This, which is separate from turning off your landscape lighting. Landscape and facade lighting have to be off during non-business hours, and there's a couple of provisions for that in the code too. But this 30% could be dimming. It could be I'm going to turn the fixtures further away from my buildings off and leave the ones closer in on. Or you can just do it via occupancy sensors. Track lighting for your load calcs. They reduce the estimated load for track lighting, or the minimum load for track lighting calculations, from 30 watts per foot to 8. Trying to put 30 watts of LED on and not overlight that room like crazy. So now it's 8 watts per foot is the minimum calculation, or whatever is installed, whichever one is higher. So that compares to National Electric Code, which is 75 watts per foot allowance. So now ASHRAE 90.1 still has it at 30. This is only IECC that changed to 8. Lighting, again, continues to get more efficient. A little bit on the office. Biggest change was libraries. That's over a 30%, 34% change for libraries. Down to 0.78. Part of this is libraries are looking a lot more and more like offices. A lot more computers, fewer stacks and stacks and stacks of books. Transformers and motors. Transformers is now gone to, is that TP1? No, DOE 2016. Transformers and motors is NEMA Premium. Those are minimum efficiencies now. The only challenge with a transformer, can you tell the difference between the two? By looking at it? Nope. Unfortunately, you end up having to go in the specs to see, did you specify a DOE 2016 compliant transformer? Fortunately, I think a lot of places don't carry ones that are not DOE 2016, because that's kind of become a national minimum standard. But, won't say they're not out there. Motors, the next generation, it's kind of easy to tell that's not a regular motor. The next generation of high efficiency motors are becoming these hybrid permanent magnet and induction motors. So that one's kind of easy to tell the difference. Renewable energy credit limits. I mentioned that sometimes there's limits as far as trade-offs. And this is one of them as far as if you're doing performance, you only get credit for 5% for renewable energy. You can put more than 5% renewables on, but your model only gets to take advantage of the first 5%, or it only can reduce the building energy load by 5%. Anything thereafter doesn't count in the model, but can still be beneficial to the client. And part of that is to prevent things such as depicted there. A solar greenhouse. I just put solar panels on to block the sun that I needed in the, so a little bit of weird. So, but so that's where they put that 5% cap on and say, we'll give you some benefit, but we don't want craziness. O&M manuals. Code now talks about O&Ms being required to be delivered within 90 days of certificate of occupancy. We understand in real life that is not really enforceable, other than the building owner should be expecting it. And as part of that, it has to be labeled as far as where in these books do I need to go find what I need. And that listing of here's the equipment, here's the PMs that need to be done on it, and here's where you go find what the PM actually is. So on the listing of equipment, it might say, hey, here's my air handler, you need to do a belt change, see, book 82, section 5, for what belt you need to change. So that's one that, other than the building owners and their maintenance staff knowing you need to be expecting this, it's unfortunately about the extent of enforcement available on it. But it's in the code now. So turn it over to Robert here to pick off residential fairly quick here.
Yeah,
Residential doesn't have a whole lot to it.
Thanks, Ray. So the residential portion of the code is broken out into these 6 different sections. Not much to see there. We've talked about air barriers. These are getting more and more. Code officials are looking. Do you have your air barrier up or not? Very critical to stop that infiltration.
Can you go back and look at that, talk about air barrier, see how that,
Up here?
yeah, there's what is that bottom part, grouted?
Yes, that is grouted. It looks like grouted and
So there's
flashing.
and flashing.
So there's a,
Yep.
So that's an improper installation then, correct?
Well, they filled that cavity and then there's a
Yes.
flashing above it. And
You have got a, well, you've got a hell of a thermal bridge right there.
That's what I'm
Yeah.
talking about.
Yeah, you do have a thermal bridge here. So that's that's not good right there. Yeah, you will get frost on that floor probably right
I
there.
mean, that's what, because I turn that stuff down. I mean, am I not supposed to?
Yeah.
Here it's in your example.
Yeah, well, we should pull that out. You're right.
Well, this is a poor example of insulation, but the air barrier, the continuous air barrier, needs to wrap into the building, and
Right.
so
Yeah.
you see the vapor barrier identified on the inside.
Unless they take it out of the equation on, if they do it's prescriptive, then no, but if they do a modeling or
Modeling or something like that, you could probably get away with that.
And they can take the slab on grade insulation out of the equation.
No, you're
You
right.
can get some
You're right.
Because it's
non-desirable
supposed to go
effects.
to the top of the concrete
Yeah.
slab.
Yeah.
Even if they take it
Yeah.
up and double it.
Right. We've got examples of that. That's a difficult detail to address,
Well, I
because
address it,
you
yeah.
bevel that, and then you get this little sliver of concrete
Great,
here
yeah.
that's going to crack. So it's a goofy detail too. I'm not fond of that either. So that's a hard detail to address. I mean, we were just asked that question just not too long ago too, and that's a very difficult detail.
My question, I'm not an engineer or thermodynamic person or whatever, but and the code only requires you to either 24 inches or 2 feet, either horizontally or vertically. A lot of details you see, like in this one here, they're going horizontally and vertically. If they did a 2-foot horizontal and vertical, you know how they'll go up and then they'll kind of do an angle and then a horizontal, but they'll bring it down and they'll have that gap there. The reason why is because if they take the insulation up to the slab, they're going to have reinforcement bars.
Mm-hmm.
If it's not a typical, if it's just they'll have reinforcement. So if they have it both horizontal and vertical, and there's that gap, does that help any, or is it from the exterior?
Well, it's from the exterior. That would help what you're talking about, but still, this is just it's a difficult detail, and a lot of times you will see, that slab sitting on something right there too, part of the foundation
Well,
wall.
that's why I asked what that other, that says grout solid below, because I've seen a detail, and I don't remember where, I've seen something that it was an acceptable method where they took on the on the interior of the brick, that grout would be like an R10, and that goes down a little bit below the slab.
That
And
would
that's supposed to, is that,
that would work, but this is fairly common, at least in my experience. This is grouting right here, but
That's part of the foundation there.
Right,
It's not part
yeah.
of the wall.
right.
'Cause the
But
slab
you
is up
get
on
that
top.
thermal bridge right
Yeah.
there. So I'm glad you pointed
I
that
mean,
out.
well, what's the grout for? The grout's just a filler
It is a filler.
for the brick, so why couldn't they just put R10 there or something?
Well, that's a good question.
I don't know.
No, I don't know if anybody else has got an answer
I'm
to
an
that.
architect or a designer, so I don't know.
Mostly because the masons would probably complain.
Yeah, that's probably true. Yeah. How many of you have witnessed a blower door test? Just a few people, not too many. These are fascinating tests, real quickly. We've done hundreds of these on the reservation. You set this panel up, and this fabric panel, it's on an adjustable frame so it can fit different door heights and widths. You put this big fan in there, and it blows air out, and it depressurizes your building. And this measures how much air is going through that. And you can tell how leaky your building is from this unit. And it's very interesting. Turn this on, then start walking around a building and start feeling where air is leaking in. You'll almost always feel around outlets on exterior walls. Can lights are notoriously leaky. I walked into a bedroom once and I thought, where is that breeze coming from? Well, the strike plate on the jamb, they had drilled through the jamb into that void between the jamb and the studs. Well, somewhere, and I don't know, I've framed houses before, I don't know where the air was getting into that cavity, but air was just whistling into the inside. It was either coming from the attic or the crawl space, getting up into that cavity and coming in. And we told them, we don't know where this air is coming from, but the way to solve this is take some spray foam and spray it in that hole. Once you stop that air from coming out, it doesn't matter where it's getting into that cavity. Now you've stopped that air from getting into the space. But you'll find leakages at the most odd places with blower door tests, and they are very effective. And you can do one of these tests in 30 minutes to 45 minutes and be in and out of the place. I mean, they're not real difficult to do. You have to make sure all the windows are closed. If there's a fireplace, that the doors are shut so that you're not drawing in, soot and stuff. Yeah. Well, we did that at one place. They put the fire out and they closed the doors, and there was still enough leakage that we couldn't complete the
I believe
test.
said vinyl flooring off the floor, that they used to put in this loose lay vinyl flooring, put the cab lifted off the floor.
I've seen
About
that.
high.
Not that high, but I've seen a flood of.
That high,
Yeah.
yeah. Big bubble.
Yeah, you'll find leakage at the most odd places in a building. So very interesting test to do, and not that difficult to do either. Building thermal envelope. We've got to put in these. We talked about the whole house fans or mechanical ventilation systems. These things are effective. They are, and a lot of companies make them. I've got some pictures here in just a moment. These are just incremental changes from the 2015 IECC. You can see the fenestration view factors in the different zones have gotten a little tighter. Not much else there. That you've seen all those labels on windows. In zone 4, you have to address solar heat gain coefficients. You don't have to do that now. It's not as much an issue. Solar energy coming in through our windows. It is down south here. Our window technology has really gotten better in the last 20 years. We can cut down a lot of this solar energy that's the visibility is still great, but we're cutting down on the amount of solar energy coming through so that our air conditioning systems don't have to work as hard. Ducts and conditioned space. We want to make sure our ducts aren't leaky. We have to test the ducts. We want to make sure they're under full depth of insulation in the attic. It's preferable to have everything within the envelope, within the air barrier, rather than penetrating into the attic or into a crawl space. That's just asking for trouble, really. So this is the ERV, heat recovery ventilation or energy recovery ventilation. This is just sensible heat right there. This is sensible plus latent. So we're bringing in outside air, unconditioned fresh outside air. It goes through a heat exchanger, and this is going to the inside. This is coming from the from bathrooms and kitchen. This is the foul air that we're trying to get rid of. Well, this is transferring that heat or coolness in the summer from one airstream to the other, but not mixing them. They're on different sides of a metal plate usually. And then you've got two different motors here. As Ryan was saying yesterday, he was telling me Panasonic, you can actually dial these in differently to different CFMs if you want. These do not use a lot of power. I think the one you looked up yesterday was 70 watts total for Panasonic. Another one from Energy Federation was 60 watts. So these are critical in our new construction. We need to get rid of the moisture.
This is not a this HRV or ERV fan. It's not a requirement. It's just an optional. It's an option for whole house mechanical ventilation.
Ventilation is required.
Right.
Yeah.
You don't have to use an HRV or
Right.
ERV to do
That's true.
that.
Okay, that's what I'm saying.
Yeah.
Yeah, you can't have the continuous, we've seen that before, the continuous running Panasonic fan just exhausting.
Or the continuous
Yeah.
or their
Yeah.
time.
Or that, yeah. This is a preferred method because you're dumping air, as I mentioned before, that you've already paid to
No, I
condition.
understand that.
you
I'm
know.
just,
And they're very effective, especially in colder climates.
Yeah.
So they're recapturing a lot of that energy before you're exhausting it. So they're very effective units. They're not effective if they're off. We were up in Alaska. One of these are filters right here. This one filter from down below, I opened the unit up. It was just clogged with mosquitoes. There was no air getting through that filter. So they need maintenance
That's their
occasionally.
state bird.
What's that?
That's their state
Well,
bird.
that's true. Yeah. I've been in places where it was just miserable, and it was just clogged with mosquitoes. So you know, there's some maintenance required with these things. You want to cover these last few?
As far as high efficacy lighting, the change in the code, moving from 90% or moving from 75% to 90%. Big one is the second bullet. Low voltage lighting exception has been removed. So every fixture counts now. It used to be, it was not uncommon where you walk into a place and you got all these beautiful little low voltage track lighting all over the place. Well, those didn't count before. As far as, do you meet the threshold as far as high efficacy lighting? The other thing is there's an Illinois amendment on this one, which high efficacy lighting for the state of Illinois is 65 lumens per watt for bulbs and 55 lumens per watt for fixtures. Which, again, we went out and found out, across 450 products that we found in the store, just down the street, 85% of them already met that threshold. And the surprising thing was, well, maybe surprising, maybe not, it tended to be the more expensive products that didn't meet the requirement. I'm not sure why. So that was one that there was some pushback as far as would that state amendment go through or not. And then after we provide that data back to CDB, they looked at it and said, it's really readily available. So they're moving forward with
I'm
that
trying
one.
to price out. I went to get bulbs one day. I was like, man, and just an incandescent light is what I wanted because of the dimming option.
Uh-huh.
Holy cow.
Yeah.
Crazy cost
Yeah.
for a regular bulb.
Yeah. Well, dimming LEDs have come dramatically.
Yeah.
They're not perfect.
Right.
I'll totally give you that. But I mean, the prices on those have fallen so dramatically. Plus, the utilities incentivizing them helps. I mean, it's not uncommon where I'm finding decent LEDs for under $1 now. Multifamily unit modeling. This is a provision to allow you to rather than rerunning a model time and time and time again, you're able to use a model and say, well, okay, these two units are identical. They're mirror images. They have the same eastern exposure. I'm assuming this is a separate unit from that. But the two in the middle, same exposure, same equipment, same layout, same floor plan. I only need one model for it.
When you say model, you mean,
This is an energy model,
okay.
energy performance model of the
So I
space.
still have to blower door test all.
Blower door test is still required.
If they're outside doors.
Uh,
Common doors, and I can just blower door them.
You can either, I think you can either blower door the entire building or individual units.
Right.
Illinois does have an amendment on the blower doors to allow you to use a surface area air leakage test rather than a volumetric test. Because of these smaller units, their volume relative to their surface area is skewed. Because 4 air changes per hour, that's a particular volume of space. Well, if you have a small unit, you have a lot more surface area per unit of internal volume. So Illinois is adding an amendment to allow you to use a surface area air leakage rate, which, to be totally honest, that's really what we're after, is my envelope, how tight is it? It's so many, I want to say, don't quote me on this, it's like 0.25 CFM per square foot of outside envelope. So they're adding that provision to allow you to use that surface area rather than a volumetric air leakage rate. So, I mentioned earlier the energy rating index. This is a dramatic increase. Used to be 54, for lack of a better term, percent of a baseline model. That's moving from 54% of that baseline up to 62%, or 61, depending on which zone you're in. This is them trying to encourage the ERI to be used. So, rather than going a prescriptive or some other method. So, that's a big, big change there. Probably one of the few areas where the code got substantially less stringent from one cycle to the next. Existing buildings, again, we noted only that which you are touching has to be brought up to the current standard. So it doesn't require unaltered portions. If you have excess fenestration, you can keep that. So a lot of times you'll see factories that may get repurposed into residential, and they'll have giant windows from the factory days. You're allowed to keep that surface area, but the U factor and the solar heat gain must meet the table requirements.
So you can increase
you can't,
30%, go beyond the 30% basically.
You can. It allows you. It allows you to go past the 30%. You cannot increase the area, but as long as it was there before, you can maintain it. So
Even with new windows, you just have to hit the U value.
you can replace the old windows with the new windows. You just have to hit your U values and solar heat gain. So, this was something that we touched on earlier as far as existing cavities that were exposed. So if you pull the drywall off, you don't have to bring it up to the full table value, but you must fill the cavity. Something that the City of Chicago came back with as far as guidance on this, and we would allow, or we would agree from a building science perspective, if you have masonry, to leave an air gap, because you need to make sure that masonry can dry, because we don't want to hold that moisture in that masonry and destroy it. Again, we're trying to preserve the buildings, not demolish them. So they allow allow the 1-inch air gap behind the masonry, but the rest of the cavity needs to be filled. So, with that, we're a few minutes over time. Any other questions you guys have for us at this point?
I did have one quick one.
Sure.
How municipalities looking to change inspection processes pretty heavily? We're actually having a meeting tomorrow night with our city council. One of the things they're proposing is a waiver of the contractor or installation installer sign that says, I'll meet this code. We don't inspect anything. What are your thoughts on that?
You know, the unfortunate part is you get what you measure. And so if you don't measure something, how do you know you got it? That is the biggest thing that I saw with LEED was the difference between a LEED certified design and a LEED compliant design were dramatically different. I observed on a building that we built on a college campus that it was called LEED certifiable. One of the biggest things, one of the huge features they had was we have skylights. Unfortunately, had you gone through and ran the numbers, the skylights weren't large enough to daylight the space. So they put in these skylights. They had skylights all over the roof, but they were so small that the lights still had to stay on all the time anyway. So I would say that anytime you end up waiving inspections, it is not uncommon where you will see performance degradation and standards will not be able to be met.
It's pretty low house thing. I bounced that off.
Yeah, I mean it's the unfortunate truth is there are many contractors out there that do excellent work, go above and beyond. But unfortunately, something that Sean had noticed was he used to do a lot of building work out in the field and noticed that the best houses that they were building were the Habitat for Humanity homes that were under constant, because you have, people knew there's volunteers building these, so we're going to be inspecting these on a much more routine basis, not from a building code necessarily perspective, but just the management is in there constantly inspecting, and did we get this right? Did we not? Okay, we didn't get it right, let's fix it. So that's unfortunately what you get.
Sounds good. Thanks.
Yeah. Okay. Didn't get to our round table, but one question I would like to leave you with, and if you wouldn't mind, you can just email us your answer from your perspective as far as what are the biggest challenges that you see as far as code adoption, code enforcement, and code design. Some of it might be we've come across before where their city council was, they were not in favor of having them enforce it. Didn't matter, it was state law. That's government overreach. We know what's best for our city. So could be certain things like that. Could be things that are on this presentation or your other thoughts. So.
Yeah, your perspective is very important to us. I mean, you guys are in the field. You're code officials, you're designers, you're builders. Your perspective is very much appreciated if you share it with us. And thank you for some of your comments too during the presentation. There are some very good points that were brought up here too.
Yeah.
Thank you guys.
Yeah. Thank
Up
you.
here doing this.
Yeah.
For coming down here.
Our pleasure.
I sure appreciate it.
Yeah, I caught that. It is. He said down. He's a Champaign River.
Yeah. Yeah.
Which is weird because I do live south of Champaign-Urbana.
You're just used to being north of it when you do these.
Yeah. So, but that's where we have been trying to get out and across the whole state of Illinois in the the upcoming fiscal year, so July 1 through June 30th. We have 5 We're anticipating 5 workshops across the state of Illinois. That's been kind of the real push from the state energy office, is we want to get out of the city of Chicago and the suburbs around it, because the rest of the state needs the help. You guys haven't had the support, assistance, and focus from the state of Illinois. Everything's been, well, this is where all the population is. Well, there's still the other 20% of the whole state being missed. So.
Not all in the woods and the tents or anything.
Yeah, there's a lot more
They still want
to
our
Illinois
tax
than
Yeah.
a lot more to Illinois than Chicago. So, thank you very much.
Thank you.